Tell us your name and tell us about your project.
My name is Edwin Hubble, and I am an astronomer working at the Mount Wilson Observatory. My primary focus has been on studying the nature and structure of the universe beyond our Milky Way galaxy. My recent project involves using the 100-inch Hooker telescope to observe celestial objects, particularly focusing on the Andromeda Nebula to determine its distance and properties. Through my work, I have discovered Cepheid variable stars and Andromeda, which revealed that it is not a part of our galaxy, but an entirely separate one. This finding suggests that the universe is much larger than previously thought, composed of many such galaxies.
What were you guys trying to do or find?
Well, we were aiming to determine the nature of the so-called nebulae observed in the night sky. Specifically, we wanted to ascertain whether these objects, such as the Andromeda Nebula, were part of the Milky Way galaxy or if they were separate galaxies altogether. By identifying and studying Cepheid variable stars within these nebulae, we could calculate their distances from Earth. Our ultimate goal was to measure these distances accurately to understand the true scale of the universe. This work was crucial in determining whether the universe was composed of single galaxies or many galaxies.
Where did the project or experiment occur?
The project took place at the Mount Wilson Observatory in California. We utilized the 100-inch Hooker telescope, which is one of the most powerful telescopes available. This observatory, situated on Mount Wilson, provides an excellent vantage point for astronomical observations due to its elevation and clear skies. The observatory's advanced equipment allowed us to observe distant celestial objects with great precision. It was here that we made the critical observations of the Andromeda Nebula and other galaxies.
What other significant events were happening around the world at that time?
During the time of our galactic observations in the 1920s, several significant global events were unfolding. The world was recovering from the aftermath of World War I, which ended in 1918, and the League of Nations was established to promote peace and cooperation. The 1920s, known as the Roaring Twenties, were a period of significant economic growth and cultural change, particularly in the United States and Europe. Technological advancements were transforming daily life with the widespread adoption of automobiles, radios, motion pictures. Additionally, the field of physics was revolutionized by the development of quantum mechanics and the theory of relativity by Albert Einstein.
Who else was involved in the project?
Several key individuals and collaborators were involved in the project at the Mount Wilson Observatory, notably Milton Humason played a significant role. He was an observational assistant who helped with many of the crucial measurements and data collection. George Ellery Hale, the founder of the observatory, provided essential support and resources for our work. Other astronomers and staff at the observatory also contributed through their technical expertise and assistance in operating the telescopes and analyzing data. Together, this team effort made our groundbreaking discoveries possible.
What was your role in the project?
Well, I was the lead astronomer. My role in the project was to direct and conduct the observations of celestial objects, particularly focusing on the so-called nebulae. I was responsible for identifying and studying Cepheid variable stars within these nebulae to calculate their distances from Earth. I formulated the hypothesis that these nebulae were actually separate galaxies and designed the experiments to test this theory. Additionally, I analyzed the data collected from our observations and drew the critical conclusions that led to the realization of a vastly larger universe. My work culminated in the formulation of Hubble's law, which established the relationship between a galaxy's distance and its recessional velocity.
What impact did your project have on the physics community?
Well, our project has a profound impact on the physics and astronomy communities. It fundamentally changed our understanding of the universe by providing that the Milky Way is just one of many galaxies, significantly expanding the known scale of the cosmos. The discovery of the expanding universe, as indicated by what they now call Hubble's law, provided crucial evidence for the Big Bang theory, which describes the origin of the universe. This work laid the foundation of modern cosmology and influenced numerous subsequent studies in astrophysics. It also spurred further research into the nature and behavior of galaxies, redshifts, and the overall structure of the universe.
Would you have ever expected a telescope orbiting the Earth to be named after you?
No, I could not have anticipated that a telescope orbiting the Earth would be named after me. During my time, space exploration and satellite technology were still in their infancy, and the idea of placing a telescope in space was beyond our technological reach and imagination. However, it is a profound honor to have such a significant scientific instrument, the Hubble Space Telescope, carry out my name. This telescope continues to build upon our work, providing unprecedented insights into the universe and furthering our understanding of the cosmos. But if I had to guess what it would look like, I would say it would look something like this.